A bomber drops a bomb from an altitude of 1,000 meters. It says determine the overall velocity and direction of the bomb travel if it was traveling at 100 meters per second when launched. Okay, so we have a bomb that's being dropped. It's initially traveling at 100 meters per second this way, and it's going to take an arc that looks something like that, and we want to know what the velocity is as it strikes the ground and what direction it's traveling as well. So really what I need to do in order to solve this is to find overall velocity, which is this v term. I need to know velocity in the x direction, which I already have as 100, and velocity in the y direction. So if I can solve for velocity in the y direction, I can then solve for velocity overall and the angle as well. So really what I'm trying to do is I'm trying to solve for velocity in the y direction. And it would be the final velocity, because we do know that the initial velocity is 0. We know that the acceleration is negative 9.8, and we know that it was dropped from an altitude of negative 1,000 meters. And in the x direction, we know that it was traveling at a velocity of 100 meters per second. So we know that we're going to use if that in the y direction, and in the x direction, we know we're going to use, well, we're not going to use anything, but we would use velocity equals displacement over time. So we look at the y direction, realize that we're trying to solve for final velocity in the y direction, so we say I've got initial, final, distance, and acceleration, and the equation that I have that doesn't have time in it would be vf squared equals vi squared plus 2a delta d. Or, as it has it on your formula chart, a equals vf squared minus vi squared divided by 2d. These two equations are the same thing. This is what you'll see on the star chart, and this is a more common form that you'll see in most textbooks. So we're going to go ahead and use this form because I am looking for final velocity. So I plug in my numbers. I say 0 squared plus 2, negative 9.8, negative 1,000. And you say, okay, 2 times negative 9.8 times negative 1,000 is 19,600. Take the square root of that, and you get the final velocity is 140 meters per second. Now, just so you realize, whenever you have this right here, you get this VF squared term is 19,600. Realize that there are actually two solutions. There's a positive solution and there's a negative solution. The only one that makes sense in this particular case is the negative solution, because the bomb has to be moving down in order for it to strike the ground. If it has a positive 140, it doesn't make any sense. So now, we're going to go ahead and plug this into our triangle that we have over here. We're going to erase this and say that we have 140 moving down. So to find the overall velocity, which is just the hypotenuse of the triangle, we use the Pythagorean theorem. We say a squared plus b squared equals c squared, or in our case, 140 squared plus 100 squared. Take the square root of both of those, and we get our velocity. Our overall velocity ends up being 172 meters per second. Now, it's not really negative and it's not really positive, because we had a negative here and we had a positive here. So really, how we're going to define this is at an angle. So what I'm going to do is I'm going to say, okay, this is the angle that I'm going to be looking for. And if you remember from earlier this chapter, we said, okay, to find that angle, I can say the angle is equal to the inverse tangent of the opposite side, which is 140, over the adjacent side, which in our case is 100. So when I do that, I get 54.5 degrees.